Hi everyone, myself Bhaskar, working as an assistant professor in the Department of Mechanical Engineering, St. Martin's Engineering College. Today I am going to give the video lecture on orthographic projections. See, orthographic projections generally it is a geometrical deals with the representation of mainly points, lines and planes, then solids. So here this combination of these points, lines as well as planes, combining all those together, we are going to call it is a orthographic projections. In that mainly first of all the points. Here it is a dimensionless. We are going to generally represent it with dot. So the dot which is having a dimensionless. Then lines. So generally the set of dots, it is called line. So which is having a one dimensional object. And then planes. Plane it is a number of combination of the lines which is forming a plane and which is a two-dimensional objects. So this is the combination of the points, lines and planes. So combine all three together, we are going to say it is a orthographic projections. And next coming to the solids. So solid is a three-dimensional objects. So now the point is there and line is there. So combination of the point which is a line and combination of the line which is a plane. Now combination of the plane which is a solid. So this all are comes under the orthographic projections. And now these are the types of the projections. So in orthographic projections deal with combination of these two. So in that first one is the orthographic projections, next one is the isometric projections, and third one is the oblique projections, and fourth one is the perspective projections. So see, so come here orthographic projection, generally we are going to say the projectors always parallel to each other and the plane is perpendicular. So that is called orthographic projections. Here it is how it is. See here the parallel. The projectors are parallel to each other and also perpendicular to the plane. So this is the orthographic projections. And now the orthographic projections we are going to call, there is a front view, top view as well as side view. And now here generally this orthographic projections, there is a, for drawing purpose we have a some notations. So that is the standard notation we have to follow. So these are the notations while drawing the front view as well as top view as well as side view. So these are the notations. For example, the front view we are going to mark with help of the small letters, that to 8 dash. So with dashed we are going to mark the front views and that we are going to use the small letters. So in the front view the point A dash which is represents the front view, and for example which is a line. So for that purpose we are going to use that is A dash B dash. Same way coming to the top view. So this is the short form TV which is represents the top view. So for the top view the small letters only we are going to use but without dashed lines. So that is the point. And line, for line purpose we are going to use which is a AB. Then side view, the short form which is called SV, and here we are going to represent the notation is A double dash, and that is the side view. And for line purpose in that point, in side view point of view, if you are going to draw a line, so that is A double dash and B double dash. So these are the general representation and the notations for the engineering graphics in orthographic projections. So the front view, that is the short form is FV, and side view the short form is SV, and the top view the short form which is called TV. And always we are going to use the points which is small letters and dashed line for the front view and double dashed line for the side view without dashed line for the top view. This is the general notation for the marking of the points. Next, these are the observations we are going to use. See, the observation of the front view, observer always right side of the quadrant. In, for example, generally before going to start the quadrants, these are the few observations like a precautions before going to draw any diagram. So these are the few points we need to consider. So observation of the front view always which is a right side of the quadrant. Then observation of the top view always which is the top side view of the quadrants. So then these are the general notations we are going to use in a engineering graphics. And here, see, these are the, before I explained, that is what are the types of the orthographic projections, how we are going to draw. So in that orthographic projections, the first thing is the orthographic projections. So here generally, see here what happened, it is in orthographic projections, what's going on, it is assumed to be the observer is infinite distance, which means, for example, there is a object. So the observer is observing from certain distance. So how the projection is going to be obtained? So here the projections lines are parallel to each other and perpendicular to the plane of the projections, which means, see here, these are the lines. These are the lines. These line each other parallel to each other, which means the lines are parallel to each other, and the main object which is there here, this one which is there, that is always perpendicular. So this is generally the orthographic projections. In orthographic projections, the line which is the projecting lines which is always parallel to each other, and the plane is and perpendicular to the plane of the projection. So this is the plane. So this is a plane. So perpendicular to this plane, the point projectors are going to be obtained. See here, the red color lines which is perpendicular to the plane, either this one or this one. This is object. The object is always parallel to the plane, and the projectors which is there perpendicular to the planes. So this is the orthographic projections. Next, always see here, there is a specific distance is the given. Another method, that is the oblique projections. Oblique projections. Here there is the difference between the orthographic projections and oblique projections. Here in the orthographic projections, the line which is there, the projecting lines always parallel to each other. But here in this oblique method, the incline, the rays which is there, the line which is obtained projecting on the plane, that is always inclined to each other. That is always inclined to each other. These are the inclined to each other but parallel. So the difference between orthographic projections and oblique projection. Here there is a object, same way. For example, it is a. Here it is a 1, 2, 3, 4, as well as that is the top position, and bottom we are going to call it is A, B, C. See now, the object which is there, the plane is certain distance and object is certain distance. So the rays, how it is inclined parallel. The light objects are inclined parallel, and this is always perpendicular to the plane. So that is the oblique projections. The main difference between the orthographic projections and oblique projection, there is a direct, it is the projector going to obtaining on the plane parallel to each other, and plane is perpendicular to the object. So that is the orthographic, and in this oblique it is inclined parallel. So that is the main difference between the oblique and orthographic projections. And next one more thing, that is the perspective object. This is called perspective object. See, perspective object means, for example, if a observer is observing at certain distance, means for example 1 or 2 kilometers or 1 kilometer, from there he is going to be observing. So here how it is, means generally I am going to explain you that. So here what is going to be obtained, for example, the observer is observing from certain distance, what will going to be happen here, for example, this is a object, this is a sphere. Now the observer is observing from certain distance. So it is from observing means certain distance, means that is going to obtain a small thing. that is going to form obtain a small things. So what we have to do, we are going to do, this is generally where the image will be zooming, the object will be obtaining like a zooming. So here that is the perspective system. See, for example, the observer is here, or not observer, it is a object, the like it is a human or any object. In the place of this, any object we are placing, then focusing, this is called the torch, which is called the observer. This is generally it is a object. So now the observer is observing, and behind this, behind the object there is a plane. So when we are focusing, this shadow should be greater than the object. So this is called perspective view. So that is the perspective view in a orthographic projections. And finally, very important topic in the orthographic projections, that is the isometric projections. So isometric projections, that is observer in certain distance. So here what is going to obtain? Same, which is both the orthographic and isometric, both are same. But here the main difference is orthographic, mainly we are going to consider, we are going to call it is in a two-dimensional object, orthographic projections to be obtaining. In isometric, that is the three-dimensional object. So that is example of solids, prism, pyramid, whatever the object in three-dimensional, that is comes isometric view. So the rays are same, the rays are parallel to the plane, parallel to each other, and the plane is always perpendicular. So this is the isometric. And the difference between orthographic and isometric, here in the isometric view, the front view, top view, side view, these three views we can see at a time. So which is having in isometric projections, there is a what we are going to see, front view, side view, top view, as well. There's three. So in that, length, breadth as well as height, these three dimension also we are getting by isometric projections, and entire syllabus is going to depend on this isometric projections. So the orthographic projections deals with points. The set of points is called lines, set of lines is called planes, set of planes is called a solids. So in that solid, there is a front view, top view as well as side view we are going to observe, in that length, breadth as well as height. These three dimension we observe by using isometric projections, and it is it is the backbone of the computer aided engineering graphics syllabus, and as well as orthographic projections. And next important, now this is every time we are going to say there is a object and it is going to rest in first quadrant, second quadrant, third quadrant and fourth quadrant. So here what is mean by quadrant? First of all, this is very important. So any object we are drawing in a quadrant means that is called, quadrants called, it is a plane. The plane divided into four equal parts and parallel to each other as well as perpendicular to each other. So the quadrants divided into four parts, that is by using the plane. So see here, these are the generally, this is a plane. So here in this plane what is going to happen? See, this is called, there is a vertical plane, and as well as this is called, there is a horizontal plane. Now we are divided the plane into four equal parts. In that, this part is called first quadrant. This part is called first quadrant. Always we are going to divide the plane from right to left. So that is the anti-clockwise direction we are going to divide the quadrant. So in that, first quadrant. So first quadrant, how it is? This is called first quadrant, and this one is the second quadrant, and this one is the third quadrant, this one is the fourth quadrant. Always the quadrant, there is a first quadrant. Now we are going to see only this part. We are going to divide only this part. Now I am going to explaining related to the possibilities of the first quadrant. So this is always this is a plane. We are divided 4 quadrants. Then going to the possibilities of the quadrant. See, why I am here, why we are going to mention, why I am mentioning this quadrants means what I said, just we are going to dividing the quadrant into 4 equal parts, that too anti-clockwise direction. So that's why here it is a quadrant 1, here it is a quadrant 2, here it is a quadrant 3, here it is a quadrant 4. So see, what are the possibilities? These are the possible cases. Means, for example, if any object is rest in a first quadrant, so how it is going to be a rest and how we are going to identify the object lies in a first quadrant. See, these are the possibilities. In first quadrant, what are the points to be considering? Above HP in front of VP. See, above HP in front of VP. How we are going to say? See, here, this is the quadrant, first quadrant. How? Above HP, because the horizontal plane, that is always a horizontal plane, which is called a point is above HP and in front of VP. For example, this is a VP, vertical projection. VP means vertical projections, HP means horizontal projections. So the point lies in between these two planes. So how it is resting? A point is above HP and a point is in front of VP. So that is the first point. A point is above HP and in front of VP. Next case, on HP in front of VP. See, same way again. Point is on HP, but where it is in front of VP, we are going to represent the point wherever it is in this. For example, on HP. On horizontal plane, anywhere, there is no specific dimension, they are not mentioning. So just what they are saying, only a point is on HP. So everywhere we are going to say, see, this is called horizontal. For example, here or here or here, everywhere it is on HP. Then again what it is? In front of VP. So in front of VP means this is the vertical plane. In front means anywhere it is a rest. So that is the point is in first quadrant, a point is on HP as well as in front of VP. Next, third possible case is that is above HP on the VP. Now see, above HP as well as on VP. Above HP means generally we are going to take from the reference line. From the reference lines, that is the vertical as well as horizontal plane which is going to be intersect. So that is the point. So here in between we are going to, from the center of the axis, means that is the plane, not axis, it is a plane, from center. It is the above HP and on VP, because this is a vertical. Anywhere this is the point going to be a rest. So that is the third possibilities of the point. Next, on the reference plane. So point is on the reference plane is there is no specific. So in center of the plane, that is called on the reference line. That is related to the first quadrant. Each and every point we are going to say these are the first quadrant possibilities. In that, the fourth one on the reference plane point, it is always, this is applicable for 4 quadrants, but starting 3 is the only first quadrant related. Next, coming to the second quadrant. See, in second quadrant, what are the possibilities to be there? Above HP, behind VP. Why behind? There is a plane. So there is a plane. For example, first quadrant is over. Now second quadrant. So this is the vertical, this is the horizontal. Now point is above HP. Always it is in HP. And where it is vertical projections, vertical plane back sides. That's why we are going to say it is a behind. So now how it is? This is the generally, see, above the HP and behind the VP. Back side of the plane. Next one is the on HP, behind VP. Same. How it is? On HP, behind VP. Next, third one is the on reference plane, above HP, on VP. Again, above HP, on VP. That is also going to be considered. That is also going to be considered. That is the second quadrant related possibility cases. Next one is the third quadrant. See how now, how I am coming? First, second, third, fourth. Means that is the anti-clockwise direction. Next is the third quadrant related possibility cases we are going to see. So that is the, now the plane is like this. So first quadrant is over, second quadrant is over. Now downside of the horizontal plane we are coming. So now a below HP behind VP. See how below HP behind VP. See this is a horizontal plane. This is a horizontal plane. Now below the HP behind the VP. This is a vertical plane. So vertical plane, now we are seeing the possibilities in third quadrant. So how it is? Behind, below. So the point is below the HP and behind the VP. Next one is the on the HP behind VP. Next, third one is the below HP on VP. Next, fourth one is the on reference. This all are comes under the third quadrants. So now fourth quadrant. Now possibility cases of the fourth quadrant is below HP. See, the plane is over. Now first, second, third is over. Now fourth quadrant is there. So see here, that is related to the HP as well as VP. Below the HP, in front of VP. See, this one. Below the HP, in front of VP. So that is the fourth quadrant related. So below the HP, in front of the VP. Next, second one is the on HP, in front of VP. So there is a point on HP. For example, on HP in front of VP. That is the possibility of the fourth quadrant related, and third point is the below HP on VP. This is the third point. And on reference. See, commonly we are going to observing the on reference plane and first quadrant, and as well as second quadrant, as well as third quadrant, as well as fourth quadrant. So this point is commonly we are going to use in entire four quadrants. So this is the quadrant related and the possibility cases of in a orthographic projections. And one more important things we are going to discuss, that is the Indians and foreigners difference we are going to say. I am going to explaining. That is, most of the cases Indians are always using the first quadrant and foreigners are always using the third quadrants because of their standard, because of their manufacturing related points. So here Indian standard BIS, according to BIS, the Indians are going to follow when first quadrants. In first quadrant, why we are selecting the first quadrants means always the point is above the in first quadrant, the point is always top view and front view. So and in the third quadrants, always that they are going to observe first the top view, the front view, then top view. So that is the main related difference between the first quadrant and third quadrants. And why we are not using either foreigners or Indians, why we are not using the second quadrant as well as fourth quadrants means, for example, if they are going to observe any object, so here there is some rules and regulations we are going to follow in the engineering graphics. So wherever the first quadrants, always the plane is, see, the plane is always, the horizontal plane is a movable plane, and we are going to rotate 90 degrees towards the clockwise as well as anti-clockwise, and the vertical plane, it is always a stationary. So when we are going to rotate in second quadrant, so the front view and top view is going to be merged. That's why the second quadrant is not going to be follow. As well as same way in fourth quadrant also, if an object lies in the fourth quadrant, so then what happened, when we are going to rotate the horizontal plane, so 90 degrees towards clockwise directions, so the object going to be merged. So there is no top view, there is no front view, there is no clear visibilities of there. That's why we are going to use the first and as well as third quadrant. Say the main difference. Right, now we are going to discuss the differentiate between the first angle and third angle projections. So these are the first angle projection, this is the third angle projections. The main difference is the symbol. So here how we are going to draw in the first angle projection and the third angle projection. See here, the first angle projection, generally we are going to draw the diagrams. The main difference between the here first angle as well as the third angle projections. Third angle projection, generally we are going to use how the object going to be obtaining in the first angle projection. See, generally the first angle projections, wherever, for example, this is a object. this is a circle. So it is a hollow circle. So the symbol how we are going to show, which is like this. So which means, and this is the possibilities of the inside. This dotted we are going to represent the inside there is a halo. So this is the first angle projections. Now the second angle projections, that is the third angle projection, how we are going to obtain the same halo circle is there, but the different is like this. So here this is the invisible. This is the invisible. So this is the third angle projections, and before that one is the first angle projections. So first angle projections. First angle projections. So in this first angle projections, see this is the object. There is a halo cylinder. So now inside there is a halo we are going to observe. And in the third angle projection, this is a third angle. So here this is a halo cylinder. There is a inside part not going to visible. That's why we are not using, the foreigner is going to be used, right? So this is generally we are going to use in orthographic projections. These are the main two difference between the first angle as well as third angle projections. Always see one more thing, one more important thing. The first angle projection as well as third angle projections, here foreigners using means that is the very important thing, that is they are going to use, and right, and those are the important things we are going to discussing in the problem. And after that, see these are the first angle projections, how we are going to represent. This is the things front view, top view as well as a side view. And this, then next one is this is the third angle projections. In the third angle projections, what will happen? See here, the reverse direction we are going to be observing. A reverse directions means first angle projections, there is a difference between these two. See the first angle projections, side view, front view as well as top view. Here the object lies between the observer as well as the plane. And the third angle projections, how it is going to rest? The object is in between, the plane is in between observer as well as the plane, right? And these are the orthographic view of the given object. So this is the first angle related, okay? And next one is the third angle related problem is going to be explained. This is the first angle. If any object we are going to place, so these are the final projection of the object. So this is the side view, this is the top, this is the front. And coming to the third angle, this is the reverse direction we are going to see. So this is the, now see the folding, after folding, this is the folding line, and we are going to see the reverse direction of the first angle, that is the third angle. So that is the third angle projections, right? So these are the things we are going to be discussing, as well as the view arrangement of the first angle as well as second angle projections. So these are the things, right? So after that, now a small video I am going to show you. So that is related to the orthographic projections, right? So this is the very important. So here mainly we are going to concentrating the first angle as well as third angle. So orthographic projections means these are the general first quadrant, how it is going to be explaining. So this is the object, generally we are going to say at a time we are going to discussing comparing the first angle as well as third angle projections, right? So these are the generally representations of the first quadrant. As this is first angle means always it is in first quadrant, third angle means always which is in third angle, third quadrant. It is the object rest. So see, you can see the difference of the how the observer is going to be observing and how the projection is going to be obtaining. These are the main difference of the first angle as well as third angle projections. So I hope this is very helpful to you, right? So now this is the main thing of the given object and first angle and related to the third angle projection of the given point.